Today we're going to talk about the different types of forces. Recall that forces are essentially just a push and a pull. They're an interaction between two objects. To give you some background on forces, I'm going to talk first about the fundamental forces in the universe. And then we'll talk about specifically the style and types of forces that will be encountered in this course. Fundamental forces represents the basic interactions within this universe. All the forces we ever encounter are just expressions of one or more of the fundamental forces. Now, it took centuries of research to whittle down the list of possible forces to these four fundamental ones, so it's worth looking into them with a little bit more detail. The one fundamental force you're probably most familiar with is gravity, or the gravitational force. This is the attraction between masses. If we wanted to be more honest, we'd say it's the attraction between energy. But that's a little beyond the topic at the moment. Keep in mind that the gravitational field, which you might have heard of, is how the gravity force interacts throughout the universe. The second most commonly heard of the four fundamental forces is the electromagnetic force. This is an attraction and a repulsion of charges and magnets. So this is where the electric field and the magnetic field will come into play. You probably already have encountered the attraction and repulsion of charges in your chemistry studies. It is important to note that the gravity force and the electromagnetic force can both act at a distance. That is to say, they don't need to be anywhere near an object to force some sort of effect or push or pull on the other object. This means they can be across the universe and still have an influence on objects, though it might be infinitesimally small. The next force discovered by humanity was the nuclear strong force. This one is a little more esoteric. It is the force that holds nuclei together. Recall that like charges repulse each other, so the protons inside the nucleus of the atom don't want to be anywhere near each other. So another force has to exist that can be strong enough to withhold that repulsive force and hold the protons close to each other. The fourth of the fundamental forces is the nuclear weak force. And this acts in kind of an opposite of the nuclear strong force. It is the force that can split an atom, and it is the one that is responsible for radioactive decay. Both of the nuclear forces are rather complicated forces to study and require advanced quantum mechanics. However, it is worth noting that they only act at a short range. Over the second half of the 20th century, physics had focused on trying to unite these fundamental forces. If it's high enough energy and density, the electromagnetic force and the nuclear weak force will combine and act like a single force. This is called the electroweak force often. Something similar was discovered in the late 1800s when electricity and magnetism were discovered to be just two sides of the same coin and actually one fundamental force. A little later, theories showed that the nuclear strong force can theoretically be combined with the electroweak force, combining three of the fundamental forces. You might have heard of the grand unified theory, and this is an ongoing effort to combine gravity with the other three fundamental forces to have a overarching theory that can combine all of the fundamental forces in the universe. However, late in the 20th century, circa 1999, a startling discovery was made. Two separate groups of astronomers were measuring distant supernova and quasars in an attempt to measure how fast the universe was expanding. At the time, all the models showed that gravity was going to eventually slow down the expansion and pull everything back inwards, Or if it was perfectly balanced, the universe would just expand on forever at the same rate that it was expanding. However, both teams independently discovered that the universe was not slowing down. It was actually speeding up in its expansion. This leads some theorists to hypothesize the existence of a fifth force. At the time, it was called quintessence, meaning fifth essence. Nowadays, you've probably heard of it, as it's more commonly referred to as dark energy. And this appears to be some mysterious and unknown force that is causing the universe to accelerate away from itself and expand at an ever-increasing rate, which may eventually tear the universe apart. Now, as far as fundamental forces go, this is a very recent discovery, and very little has been learned in the ensuing years. If we wanted to rank the four forces we know a bit more about in order of their strength, the strongest force on one side and the weakest force on another, the order might surprise you. The strongest of all the forces might not be surprising that it happens to be the nuclear strong force, hence the name. Not too far behind the nuclear strong force is the second strongest force, the electromagnetic force. In truth, it is the electromagnetic force that is responsible behind almost every single force you encounter in your day-to-day life, if you look at it close enough. Below the electromagnetic force is the nuclear weak force, which, though it's called weak, is surprisingly strong. The weakest of the four fundamental forces, surprisingly enough, is gravity, and it is substantially weaker than the other three. It is approximately 10 to the 25 times weaker than the nuclear strong force. Although gravity is substantially weaker, it does tend to dominate things on a cosmological scale. This is in part due to the nuclear forces only acting on short ranges, and that the electromagnetic force only acts when there is a net charge that is either positive or negative. Because galaxies are essentially neutral, the only real force that impacts the motion of a galaxy is gravity. And of course, dark energy.